Hi, today we're going to consider the derivative of power functions, or power type functions. Power functions are general power function f of x is a being any real number, x to the r. A is a real number, r is rational, which we use as symbol for rationals. And anything of this form then has a very nice derivative rule associated with it. So, let's suppose that I start off with y equals 2 times the square root of x cubed plus 7 times the fifth root of x squared minus 11 times the fourth root of x, all divided by 3 times the sixth root of x to the fifth. Now you might say this does not represent a power function, and you'd be correct. However, through algebra, we can rewrite this in the form of the sum of power functions. So, and this is the simplest, easiest way to do this if I want to take the derivative. So let's rewrite this. This becomes 2x to the 3 halves plus 7x to the 2 fifths minus 11x to the 1 fourth divided by 3x to the 5 sixths. I remember rules of exponents, which then becomes 2x to the 3 halves divided by 3x to the 5 sixths plus 7x to the 2 fifths divided by 3x to the 5 sixths minus 11x to the 1 fourth over 3x to the 5 sixths. Remember basic rules of algebra. To add fractions, you need a common denominator. A over c plus b over c is equal to a plus b over c. Well, we can reverse this. This denominator goes to each and every individual part. We can break it apart. And then this becomes 2/3, and now using rules of exponents, I subtract the exponents. Let's see if I can do the subtraction correctly. 3 halves minus 5 sixths is 9 sixths minus 5 sixths, which is 4 sixths, or 2/3, plus 7/3. X to the 2 fifths minus 5 sixths. I need a common denominator of 30. This is 12 thirtieths minus 25 thirtieths, which is negative 13 thirtieths. And check that. 12, 25, yes. And my final negative 11 thirds x to the, again, my common denominator is 12, least common denominator. This is 3/12, this is 10/12, and so that gives me negative 7/12. Now, this is the original function. I have not taken the derivative yet. But all of this simplification is necessary. Now I will take the derivative. Make sure you write that we are dealing with a new function. This is not the same function. The derivative is not the same as the original. That would be like saying that you and your father or mother are exactly the same. Well, I don't think that you would agree with that. So now I can take the derivative using my power rule, the general power rule derivative, the derivative of x to the, well, ax to the n is a stays, the derivative nx to the n minus 1. So in this case, the 2/3 stays. The derivative of x to the 2/3 is 2/3 times x to the subtract 1, negative 1/3. The 7/3 stays. The derivative here negative 13/30, x to the, and subtract 1, and I get negative 43/30. Minus 11/3, that stays. The derivative here, negative 7/12, x to the negative 19/12. And now we just simplify. So my final derivative then would be 4/9, x to the negative 1/3, minus 91/90. If I did my multiplication correctly here, x to the negative 43/30, plus, and we get 77/36, x to the negative 19/12. And you can just leave it like that. That would be your derivative. Kind of messy, but we like fractions. Okay? Now, one of the main things that students have issues with, and so I want to do some examples, is recognizing that a function can be written in the form of a power function. This is going to become important later on. For example, let's suppose that I have capital F of x is equal to 2 tangent cubed of x. Now, this is a composition, but the outside function is a power function. So what I mean is that I can say that little f of x, let me do it this way. Little g of x is tangent of x, and little f of x is 2x cubed, and then capital F of x is f of g of x. If I take this being my inside function and input it in, then I get the composition, gives me the original function back. Notice here that we have a basic power function on the outside. Similarly, another example, if I have capital F of x is equal to 4 over 2x plus 3 quantity cubed. Again, I can write this as a power function. I can write this as my little g of x, the inside function, being 2x plus 3, and the outside function, f of x, being 4x to the negative 3. And notice that we get exactly what we started with.